First one is false, second one is true. It's a conjunction, so I look under the conjunction and I see it's false. And so, false. Is everybody following along where I'm getting these answers from, right? Okay. Do another. Number 5. Is Z then X then Y? Okay, Z is false, then X is false, then Y is false. So the first thing I need to calculate in the innermost brackets is that false, then false. So I look at line 4, I go over to the conditional, and I would see the answer is true. So I write the answer under the operator, true, and then I'll just bring everything else down. So what I'm left with then is false, then true. So I look for the case where the first item is false and the second is true. That's line 3. Go over to the conditional, and I see that it is true. So the truth value of this for those truth value assignments is false. Any questions about this? I'm just using this table, and using this table is 90% of this chapter, right? And it's open book, so I don't want anyone getting anything less than a 90. Yes?
So what are we in the boxes?
Okay, how do you use the boxes? Okay, you can disregard the boxes and do them on scrap paper if you want, but this is how they were intended. Look, the book, when it was hard copy, had tear out sheets, and so people would do their homework and tear it out and hand it in, okay? And so if I left just a space there, I would get chicken scratch all over the place, and it was really hard to follow their work, right? So this just allows you to, like, I would put in, on this line, I put in the values. False, false, and B would be true. Then I do the calculation, not, and I would put true under that, right? And then I would bring everything else down. So you can look at the example up above, and that shows you how you can use those, right? But you don't have to, since you're not turning it in. And as far as the quiz goes, when we get to it, the question is, do we want these boxes, or do you find those confusing? You just rather have space and have me hunt through the chicken scratch? Okay, so we'll try it without this grid stuff. I think the thing that made it confusing is he right-hand justified it, so it pulled everything across the publishers. So, okay. 1, 2, 3, 4, 5. So, given that, you should be able to do 3.1. So you should be working on 3.1. Of course, that is after you have completed your chapter 4 test, right? Okay. 3.2, we're doing the same thing, except we've got L, M, and N added to the mix, and the truth value for these is unknown. Okay? And so what I'm asking you is calculate the truth value of the statement if you can. If you can, you tell me what the truth value is, and if it can't be determined, then you tell me it's unknown. Okay? So let's do a couple of these. So I'm looking at 3.2, number 1. Okay? And this is on page 242, on the book page number. Okay, so number 1 is M, then A or L. Okay. All right. Let's put in the truth values. Well, M is unknown. So what I'm going to do is I'm going to represent the fact that it's unknown by saying, on the one case it could be true, on another it could be false. So that's the way I'm representing could be true, could be false. Okay? Then, and now I know that A is what? True, right? Or L. Now L is also unknown, and L could be true or it could be false. So let's see if we can figure anything out here. So A is true, so I'm going to assume, I'm working inside the brackets first, that A is true, and I'm going to assume that L is true, okay? So true or true, that's case one over there. Go over to the or, and we see that the answer is what? True. So I'm going to say, well, on the assumption that L is true, this or thing is true. But L might be false, so let's see what happens there. True or false, that's line 2. Go over to the or, and you see that it is what? True. Okay. So it didn't matter what L was, it comes out true. Does everybody understand that? So I can just write the result, hey, this is true over here. So now what I have left to calculate is the M, which is true or false, then this, which we know is always true. Okay? So let's assume first that M is true. True, then true. So that's line 1. Look over to the conditional. What's the answer?
True.
True. Okay, so on the assumption that M is true, the conditional is true. But let's assume M is false. False, then true. That's line 3. Look over the conditional, and what do you get? Okay, so it didn't matter what M was, this final thing will come out true. If these match, true, true, the whole result is true. If we ended up with, well, no, false or false, we could say the whole thing is false. If somehow we got true for one assumption and false for another, or false, true, in those cases we would say unknown. Does everybody understand that? Okay, so let me do another to make this help clarify this. Okay, so I'm going to do number 3 now. M or not A or X. Okay, this one we know a few more things. Okay, let's put in the values. We don't know M, so I'll say it could be true, could be false, or not A, and A is true, so not true, or and X is false. Okay. First thing to do, eliminate all the negations that you can, so I can get rid of this. I can, not true is false. So I'm just going to rewrite everything, having just gotten rid of that negation. Okay. Now I need to work within the brackets first. False or false, that's line 4. Look over to the or, and we see false or false is what?
False.
Okay. So now, let's bring everything else down. This could be true, it could be false, and we have an or. So let's first assume M is true. True or false, that's line 2. Look over to the or, and what do we get?
True.
True, okay. But now let's assume M is false. So we have a case of 2 falses. That's line 4. Look over to the or, what do we get? False. So if M is true, we get this whole thing is true. If M is false, it turns out false. So do we know what the truth value of this is? No. So we would say unknown. Okay. Now, let me say one thing. People are tempted to do the following. Suppose you have something like this: not A, then B. And we're assuming that and B are true. And so what people do is they do this. They say, well, there's a negation outside, and A is true, so I'm just gonna do this. Since A is supposed to be true and there's a negation out there, I'm gonna say false. And since there's a negation out there, I'm gonna put false. And then they try to calculate it this way, right? No, can do, okay? You have to go calculate inside the brackets and then negate the result. Don't negate the inputs on the way in. Don't disregard that negation sign. Does everybody understand that? That's just like when you guys were doing this, not X and Y. You want to say, isn't that the same as not X and not Y? And the answer was no, it's not. Right? So you have to do it step by step. Okay? You might get lucky and get the right answer sometimes doing it that way, but as a rule, it does not work. Okay, so please don't do that. It took me quite a while to figure out how people were missing some of these problems because that's what they were doing. Okay, let me do 5. 5 is interesting. Not and if and only if N, then L. So we don't know anything, right? Okay, so first of all, N could be true or it could be false. We'll represent it that way, if and only if. Now, forget about this negation sign. So if this N is true, N is the same thing as N, so we have to assume this one is true, and we have to assume, when we're assuming this one is false, so that one is false, okay? But of course, we have a negation sign out there. And we'll just leave the L like that. So the first thing we have to do is get rid of the negation. So if we're assuming that N is true, N would be what? False. And if we're assuming that N is false, N would be true. So what we really end up with is this, then L, okay? And everybody understand that when I'm doing the first assumption, I'm using the tops, as it were, the numerators. And when I'm doing the second